Babylonian Mathematics, Quadratic Problems, Example 9.1. Solve for x if x squared plus 10x equal to 4, and we want to use the method of completing the square. So when we're using the method of completing the square, and the example I have again is x squared plus 10x equal to 4, leave some room because you're going to be adding something to the 10x. All right. Now, the process for completing the square, we have to note that in our example, a is equal to 1. If a were not equal to 1, we would have to divide every term by whatever a was so that a became equal to 1. All right. So you want to have a 1x squared. Once you have done that, all right, you want to take the constant term and get it over to the right-hand side. Now, in our example, the constant term was already on the right-hand side, so we're all set to go. I want to take the middle term and multiply it by a half. So I want 1/2 of 10. That's going to give me 5. Then I'm going to square it. 5 squared is equal to 25. And that's what I'll be adding to both sides of my equation. So what I end up with on the left-hand side is x squared plus 10x plus 25. And on the right-hand side, I have 29. Now, the trinomial on the left-hand side is a perfect square trinomial. I know that because I've just completed the square. So you take this term, it's a positive 5, and that's what you get. You get x plus that term, quantity square, equal to 29. So what we're going to do is we're going to use the square rooting property. I have something square is equal to 29, so whatever that something in has to equal plus or minus the square root of 29. So I have x plus 5, whoops, is equal to plus or minus the square root of 29. And now I need to solve for x. I can just add -5 to both sides, or transpose that 5 to the other side. So I now have x equal to -5 plus or minus the square root of 29. And if you want to, you can go ahead and get an approximation using your calculator. -5 plus the square root of 29 gives me 0.3852. And x equal to -5 minus the square root of 29 gives me -10.3852.